homework then, I better start recording this. Okay, so you had to find angle A and B in each of the following diagrams. Remember to show as much work as possible. 0 is the center in each case. So if you'd looked at the video, you would have seen I had been doing a little bit on circles, and one of the things that we did on circles, so there's so many of these theorems or corollaries that repeat one another, and I have already looked at this theorem with you. The theorem is that the angle standing at the center of the arc is twice the angle standing on this. The angle standing at the center of the circle is twice the angle on the same arc. I'll just write that up here. So the angle standing at the center of the circle is twice the angle on the same arc. So you will often see with and even if you look at this in your book, it'll go on about the diameter, and that a line which shows the diameter in a circle, the angle on the same arc is 90 degrees. That's the exact same as this here, only this one will get you through. Oh, you can't see. Hold on a second. My internet is best in the countryside, so sometimes you won't be able to see what I'm doing. Okay, sorry. Thanks, Ernestus. So the angle standing at the centre of the circle is twice the angle on the same arc. That's something that will see you through all of possible questions, as opposed to something as narrow as the diameter and a 90-degree angle. Okay, so when we look at this then, we can see that if we just look at question A here, question I. So question I, we have 110 degrees. Now, something that you needed to remember here. So you see that A is very straightforward. We can take 180 minus 110 degrees equals 70 degrees. Okay, everyone should remember that. Now, one of the other theorems that we covered was, and I'll type it because I know you can't bear my writing, the exterior rear angle in a triangle is equal to the sum of the two opposite interior angles. That was one of the that was one of the theorems that we did before Christmas. Now, that's one thing that you need to remember here. The second thing that you need to be able to see, can anyone tell me what this line here and this line here are? In a circle, a line that goes from the centre to the circumference is called what? Yes, Susie, radius. So we can see that both of them are radii. What does it mean if both of them are radii? What's it mean about their length? Yeah, the two radii, so those lengths are the same. And what type of triangle do we have that has two lengths the same? If you can't spell it, just throw it in, just put in whatever shape or form I'll get. A triangle that has two sides that are the same length. Yes, isosceles, good woman. So, isosceles. What does that mean? That means that these two angles here, B and A and that little blue one, the blue angles are equal. And we know that the exterior angle is equal to the sum of the two interior opposite angles. So on that note, what I can do is I can say 110 divide by 2 gives me 110 divided by 2 gives me 55 degrees, which is equal to B. That was a tough one, but again, it's about stopping and saying, what do I know? They are not asking me to find a cure for cancer here. They're giving me some sort of information that I can use. Like, the diagram has to give you some information that you can use that will solve it for you. Okay? Anyone get that or got it in a different way? Because I know there's a lot of you who didn't probably get that. So was there anyone that did get it or got it in a different way? Okay, Kelsey, can you tell me how you got it? You can type or speak, it doesn't bother me. I'll just give you a second to get that up there. I'll move on to the next one and then I'll just come back. Just because the reason I want to know how you got it in a different way, because there's often 2 or 3 different routes of going about this. Like, for example, in that question, I found that this was 70 degrees. As soon as I realised that this was an isosceles triangle, I could immediately go, right, that's perfect. This is 70 degrees, then these base angles are equal. So that leaves me at 110 and that leaves me at 55 in each angle. Okay, so there are a couple of ways that you can do this. You might also, trying to think, is there any other way? No, if you have a different way of got a different way, just figure it out from taking, and then find A and then using that. Yes, so then that's what you did there with the 3 angles in a triangle equal 180. You found A and then you recognised that these 2 were going to be base angles. Perfect. Okay, that's fine. The next one then. So we have, now let me look at this. So first of all, where we can see that there are radii. There are radii in 3 parts here. I have a radii here, a radius here, a radius here, and I have a radius here. I can tell that they're radius because centre point to the circumference, centre to the circumference, centre to the circumference. Okay? On that note then, we have, if that's the case, I can immediately see an isosceles triangle there, which tells me that A is equal to 32 degrees because I can see that isosceles triangle. Now, you can go ahead then if you wanted to and find out what this angle here is, subtract it from 180 degrees and then get angle B, which is probably what a lot of you did. You could also say that if this is 32, we can see that, or you could use our knowledge there of the angle standing at the center of the circle is twice the angle on the same arc. This is going to be 90 degrees. Okay, so I can subtract 32 from 90. That will give me my base angles here. And then, because this is an isosceles triangle, I can go with 180 degrees. Similarly, I can take the exterior angle of a triangle is equal to the sum of the 2 interiors. completely up to you. Okay, so let's just go with, I'm going to be a little bit awkward and go with, I'm going to call this C, and I'm going to use our theorem. So from our theorem, I know that C plus 32 degrees is equal to 90 degrees. Okay, so on that I have 90 minus 32 gives me 58. So therefore C is equal to 58 degrees. I know that that's an isosceles triangle. So the angle ABCD, then therefore D is equal to 58 degrees. And on that, if I add the two of them together and subtract from 180, so 180 minus 58 minus 58, that will give me 64. So therefore, B is equal to 64. Okay. Again, like I said, there's 3 separate ways in which you could actually figure out what that triangle is. If there's any questions, let me know on that so far. Okay, I'll have a check there in a second if anyone does have questions. Okay, the next one then. So, again, and just so you know, I haven't prepared any of these. So I purposely not prepared them before the class because you need to see how my thought process is. So what do? I try and figure out if I can find certain angles, okay? If there's certain information there that will actually help me, all right? So, couple of things on this then. This one here, what I can see here is that here's the diameter, okay? So now I can use my theorem. That's my theorem. I'll actually just stick a number on that for the guys that aren't here. Oh, my theorem has disappeared. Where's my theorem? There we go. So just let me bring him down here. So I'm just going to put a theorem or a number on that. I know it's not number 1, but just so you know what we're actually doing. Okay, so from my theorem number 1, because I can see a diameter in this question, then I know that this angle here and this angle here is 90 degrees. So from my theorem, that's the theorem that I had up the top there, I can see that this angle here and this angle here is 90 degrees. Any questions on that? Okay, perfect. So on that basis, I'm just going to mark them in here. It'll make our lives a little bit easier when we're trying to find the angles. So now I know those angles, I can very, very, very simply say 180 degrees minus 31 degrees minus 90 degrees will give me B. And if I take them away, 180 minus 31 minus 90, that gives me 59 degrees equals B. Okay. And then similarly, A, I just say 180 minus 63 degrees minus 90 degrees. So 180 minus 90 minus 63, I get 27 degrees is equal to A. Okay. Any questions on that? So again, sometimes you look at these and you'll say, oh, it looks like a right angle triangle, but that's where you need to be able to say about the theorems. So you need to be able to say from the theorem, this theorem, okay? The angle standing at the centre of the circle is twice the angle on the same arc. We know that this is 180, so that means that has to be 90 degrees. Okay? The next one then. So we have this one here. Okay, so looking at this, again, a lot of information, but we can still use that angle standing at the centre of the circle, okay? If needs be, we may not need to use it. So, the angles that they want us to find out is A, and they want us to find out B here, okay? Now, the only problem with this diagram is that it can be, it is a little bit confusing. I don't know why I have red lines there, guys. Can you just go my mirror for a second and start again? Okay. Okay. If you can see red lines here, I don't know what's going on, but it's not on my explain everything, so it's not on my iPad, so I don't know what's going on there. Okay, so when we're looking here, oh no, just let me on my internet. Okay, perfect, we're back. Okay, so yeah, it's very easy to see here that these diagrams aren't ideal because they're overlapping and they can cause a little bit of confusion. Don't panic about them, okay? What do we know? I can see that there is a triangle here, okay? So on that note there, that there is the diameter. So I know for a fact that this whole length here is 90 degrees, okay? So if that's 90 degrees, I then know that A is equal to 180 minus 90 degrees minus 30 degrees, which is going to give me 9, 10, 11, 12, 60 degrees. Okay, so you're just trying to visualize two separate triangles. Any questions on that? Think everyone's okay on that? Yeah? Okay, so the next one then you have is, if we look, I suppose the best thing to look at here, well, we're going to do something today on this, about the perpendicular line or the diameter here bisects. So we call this a chord, and this diameter bisects the chord. So actually what should happen there is that these two here should be 90 degrees, but obviously this is not. This is telling us that it's 100 degrees. But on that note then, if this is 100 degrees, what we can say is that this angle here, which is, let's call it C. So then C is going to be 80 degrees. Okay. And then on that basis, we can say that B is equal to 180. And I'm going to look at this triangle here. So I have 180 minus 60 minus 80, because we know that C is 80. And that will give me, B is the value of 100 minus 60 gives me 40 degrees. Okay. If there's any questions, you have assembly at 11. Oh, sugar. Okay. Guys, I tell you what, I'll finish off this video. I'll leave you go to assembly. I forgot all about you having assembly at 11. I'll leave you go to assembly and I will finish this video. And what I'll do is I'll just create a video on the circle and I'll pop that up, the rest of the circle, and I'll pop that up for you for Tuesday. Is that okay? Okay, guys, I'll leave you go then to your assembly. Okay guys, so last question here. Again, same thing here. We know that this angle is going to be, this one here is going to be 90 degrees. And on that basis, I'm going to be able to find angle B because of the triangle here. Okay. I'll be able to find angle B. So B will be equal to 180 degrees minus the 36 degrees minus the 90 degrees that we know we've just marked in there. So if I take them away, I got 180 minus 36 minus 90. And that'll give me B as the angle 54. So equals to 54 degrees. Okay, so that's going to be angle B. Now, again on this, we need to look and see. I'm just looking, I'm like, how am I going to find A? Okay, what information do I know? So I have this big diameter, this one here, perfect. I actually have, look, anytime there's a circle involved, look for radii, okay? So I can see that I have radii here, and here, and here as well, but I don't really need to worry about there for the moment, because all I'm looking for right now is angle A. So if I have radii, oh sorry, not there, what am I doing? Not there, rub that out, it's going to be here. Okay, radii being, a radius being from the center point to the circumference. Okay, what I had there was the chord. So now I can see that if angle B is 54 degrees, which is what we just said, then this angle here is going to be 54 degrees as well. So angle A is going to be 180 minus 2 by 54. And when I stick that into my calculator, 180 minus 2 by 54, that will give me 72 degrees. Okay.